Parallelogram law of vectorization. The statement of parallelogram law is as follows. If two vectors are represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then the resultant is represented both in magnitude and direction by the diagonal passing through the same point. This can be explained as follows. Let us consider OP and OQ. These are two vectors which are two sides of a parallelogram drawn from a point O. Suppose OP is represented as P bar and OQ is represented as Q bar. The diagonal OS, which is equal to R, will represent the magnitude of the resultant of two vectors P bar and Q bar. We know that for a parallelogram, opposite sides OP bar and QS bar are equal, as well as OQ bar and PS bar. These are also equal. It can be stated as OP equals to QS equals to P bar and OQ equals to PS equals to Q bar. Let us try to calculate the magnitude of the resultant of the vectors, that is R bar. As shown in the figure, OPSQ is a parallelogram drawn from the vectors OP bar and OQ bar. OS bar is the principal diagonal and which can be represented as resultant of the two vectors. Let us draw a normal from S to the OP extended which meets at the point N. Now we have two right angle triangles, triangle ONS and the same time triangle PNS. From the right angle triangle ONS, applying Pythagoras law, OS square is equals to ON square plus NS square. As we know that ON is the sum of two components OP and PN, we can write as follows. OP plus PN whole square instead of ON square and NS square. Expanding this using the formula, we have OP square plus PN square plus 2 OP PN plus NS square. From this, after rearranging, we may have in this pattern OP square plus PN square plus NS square plus 2 OP PN. From the right angle triangle ENS, ES square is equals to PN square plus NS square. So, instead of Pn square plus Ns square, if we substitute for Ps square, it takes the form like this. At the same time, we are having from the triangle ENS, Pn is equals to Ps cos theta, that is equals to Q cos theta. At the same time, Ns is equals to Ps sin theta or equals to Q sin theta. After substituting all these in this expression, we may arrive at OS square equals to OP square plus PS square plus 2 into OP into PS cos. Simplifying this, we may have R square equals to P square plus Q square plus 2 PQ cos theta. R is equals to root of P square plus Q square plus 2 PQ cos theta, which is the expression for resultant of the two vectors. Now, it is the time to find direction R, which makes an angle alpha with the x-axis. So, once again, from the triangle ONS, tan alpha is equals to NS by ON. That is equals to NS by OP plus PN. That is equals to Q sin theta by P plus Q cos theta. Or alpha is equals to tan inverse Q sin theta by P plus Q cos theta. Here, alpha represents the direction of the resultant with the x-axis.